Okay guys, so now we're on 10.1 and this is called conics. Congratulations, 10.1 is almost done. All you guys have to do is use your textbooks to define those vocabulary. Now, even though you guys are defining parabola, I thought this is a hyperbolus. But so these are the conics that we are going to study this year. We are not going to study hyperbolas, okay? We just don't have time for that this year. Now, in 10.2, I would also like you to use your textbook and find the definition of those as well. All right, guys, example 1 says, find an equation of the parabola with the given information. And then it went on and said, find 2 points that define the lattice rectum. Now, remember to define all the vocab first before you continue with this. Otherwise, none of this is going to make a lot of sense to you guys, okay? Then graph the equation by hand and label the directrix, axis of symmetry, and where the lattice rectum is supposed to be. All right, so let's start with the vertex. It's given to you as 4, -2. So let's just make some tick marks here. So we already know this is a parabola, okay? The directrix is 4, -2. So that means I'm going to go right 4, and then I'm going to go down -2. This is your vertex. Let's label it V. Next, what we want to do is, remember, the focus is at 6, 5, 6, okay? 6, -2. So here's the focus. And if you guys have already defined the focus and the vertex and the axis of symmetry, then students, the distance from here to here is the A value, okay? So immediately we know A value will be 2 units long. Next, what we want to put it in your equation is going to be, remember, the focus is always going to be on the inside of your parabola. So since the focus is on the right side of the vertex, we know it's going to open to the right. So with that said, we are going to have this formula right here for your opening to the left and right quadratic. So y minus k quantity squared equals 4a times x minus h, okay? Now this is going to look very funky because we have not studied sideways parabola before. We have only studied open it up or down, but that's okay. It's our first example, and then we're going to do some more to kind of get the practice in. So we already know the vertex is always going to be h, k, which we have, okay? So we can totally fill that in. Your h is going to be 4. So this is x minus 4. Your k is going to be -2. So this is going to be y minus a minus. So this is going to be a plus. Okay. Now we know the 4a. Okay. The 4 will stay. It opens to the right. So this quantity right here, 4a, will always be positive. A was found by counting the distance between the vertex and the focus. So that's going to be 2. So 4 times 2. And then we're going to rewrite this as our final equation. So 8's in the front. Okay, so this is what we can box up now because that's the equation of the quadratic. Now it also said, okay, well, now give me 2 points that define the lattice rectum. Well, students, the lattice rectum, usually I'm kind of shortening it as L dot R, okay? It's going to have a total distance of 8 units, okay? It's always the distance, and it's always the distance of 4a. In this case, it is going to be 8 units total, and it is the distance from the focus. So that means it's directly 4 to the top, 2, 4, and then 4, which I need to make a couple more tick marks. Okay, 4 from the 1, 2, 3, 4 from the focus on the bottom. So the 1, 2, 3, 4, right there. Okay, so this right here, students, is the total length of your lattice rectum. And your focus, okay, is going to be running through that line. So what's going to happen is your parabola is going to go opening sideways this way, going through those 2 points of lattice rectum. So it says, okay, now define 2 points. So that means your LR, the 2 points are 6, 2, 6, -6. Okay. Now try not to memorize where these things, try to see the relationship of what the focus. Okay, so you can just see that, oh, you know what, I'm just going to add 4 to both, add 4 or minus 4 to, all right. You want us to label the directrix, okay? So students, the directrix is going to be behind the vertex, okay? And is exactly, okay, exactly A units behind. So because A is 2, the directrix is this one right here, and yes, we have to label it. It's crossing over the x-axis, so that's going to be x equals to 2. And so let's go over here, directrix, x equals to 2. Then axis of symmetry, this is the same as algebra 2, is going to be running through your vertex. And yes, we do need to label it. It's crossing the y-axis, so that's going to be y equals -2. And AOS, y equals -2. And it said, okay, well, tell me the length of the lattice rectum, which we also have. So students, let's just box up all of our answer. I'm going to use a highlighter. We graphed it. These are all the stuff that they wanted us to find. Equations of parabola. The vertex at h, k, and axis of symmetry parallel to a coordinate axis when a is bigger than 0. So that means when a is positive, okay? So all of your vertex, all of these forms right here, we will always use h, k as a vertex. Okay, now you will have a focus. The focus is going to be h plus a, k. You will have a directrix, x equals h minus a. And remember, it will make more sense if you guys do the vocabulary and the example above, okay? Your equation for the parabola is going to be y minus k quantity square equals 4 times a times the quantity x minus h. Now, because it's y square, it's going to, this is called axis of symmetry. AOS is axis of symmetry, is parallel to the x-axis, and it opens to the right. Oops. Okay. Next one, we will have the equation of y minus k quantity square, and we will have negative 4a, and we have x minus h here. Now this, because it's negative, it opens to the left. Opens to the left, okay? And the axis of symmetry, it's still going to be parallel to the x-axis. Now, we are going to have the focus as at h minus a, k, and the directrix will be x equals h plus a. Next one, we will have something that opens up, which you guys already know how to graph. Opens up, meaning that the x will be square. So x minus h quantity square equals 4 times a, so that's positive. That's why it opens up, times the quantity of y minus k. Now the axis of symmetry, it's parallel to the y-axis. Okay, and again, make sure you guys define the vocabulary above on the prior page before copying this down. And try example number 1. Now your focus will be h, k plus a. And the directrix will be y equals k minus a. you will also have a parabola that can open downward. Okay, now the axis of symmetry is still going to be parallel to the y-axis. The equation is slightly different. It's just going to be a minus instead of a plus. So this is minus 4a times the quantity of y minus k. Now your focus is still h, but it's going to be k minus a. And the directrix will be y equals k plus a. On B, I'm giving you guys the focus, which is -1, 2, and the directrix at x equals to 3. So the first thing you always want to do is to do a little sketch of that. Why do I need that? Okay, so let's make some tick marks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. Let's plot. Ready? Focus is -1, and then up 2. I'm going to use F for focus, so I know what it is. Then the directrix is x equals to 3. 1, 2, 3. So here is the directrix. Remember, the directrix and the focus, directrix. Okay. So in the middle of the focus and the directrix should be your vertex. Okay, so let's find the distance right in the middle. So this right here is right in the middle, which is your vertex, which we have, that is 1, 2. Let's write that down. Vertex is 1, 2. Now we know since the focus is on the left-hand side of the vertex, we know it opens to the left. Okay, then if it opens to the left, let's go and see if we can write down the formula. The formula is going to be y minus quantity, y minus k squared equals -4 times a times x minus h. Now let's find what a is. Remember, a is the distance between the focus and the vertex, or the vertex and the directrix, okay? And it looks like it's 2 units. So this here is 2 units. So a equals 2. So with that, we can quickly write an equation. Y minus k is 2. So that's going to be -2 squared equals -4 times 2. I'm just going to write straight up 8, okay? Times x minus 1. Let's box it up. That is our final equation. Now we will define the lattice rectum length, LR. The length is going to be 8 units, okay? 8 units. And how do I know it's 8 units? It's always this right here, okay? The lattice rectum is always the absolute value of 4 times a. So this is going to be your lattice rectum. Now, because I do know it's 8 units, let's go and finish graphing it. That means I'm going to go up 4 units from the focus. 1, 2, 3, and 4. I'm going to go a little bit above there. 1, 2, 3, and 4. With the dot, I can now sketch out my graph just like that. If you miss your dot there, just make it fatter. Now we will also find the directrix, or label the, axis of symmetry. Okay, AOS, which is now y equals to 2. Y equals to 2. Okay, let's write in here. AOS, y equals to 2. Box that up. What else are we missing? The 2 points of the lattice rectum. And we can simply just look at the graph, or we know the 2 points for lattice rectum. We know the focus has an x-axis at -1. So we both know both of those are going to be -1. Now the lattice rectum length is 8, so that means we're going to add 4 and subtract 4 from the focus y-coordinate. So if I add 4, that's 6. If I minus 4, that's -2. And then box that up. Bam, just like that. Let's try one more right here, okay? So for this one, it says the vertex is at 0, 0. So let me make some tick marks. I'm going to get it black to make tick marks. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so let's plot the vertex right away. 0, 0. Let's label it V. And they gave us the axis of symmetry of the the x-axis. Okay, so that's right on the x-axis. Okay. Oh, where did that go? There you go. So right here is AOS. AOS. Okay, what else did it give us? And it contains a point 2, 3. So when you see the contains a point, that means 2, 3 is going to be on the graph. So let's plot that point. 2 up 3. So it's on that curve. Okay. We don't know where the focus is. We don't know how far the latus rectum is. So let's go and figure this out. We know if the vertex is at the origin and there's a point on the right side, we at least know it opens to the right. Okay. Then we know at least if it opens right, the focus, okay, it's a unit from the vertex. So that means whatever h is, we could add a, and k should be the same. Well, what else do we know? We also know the directrix is behind it, right? So directrix is going to be x equals h minus a. We need to figure out this a value really bad, don't we? All right, so let's write down the equation. We know it opens right, so let's just write down the formula first. So it's in our brain, okay, just like that. Well, h and k are both 0. So that means this is y squared, 4 times a, and then just times x. Well, let's find a. They gave us a point, 2, 3. So let's plug that in. 3 is y, so that's 3 squared equals 4 times a, and 2 is x, so this is 9 equals 8a. Divide both sides by 8, so a equals 9 over 8. Okay, not a friendly number, but that doesn't mean it's not a number, so let's go and fill in our focus. So focus will be now h plus a. H is 0, so that's going to be 9/8, 0. Let's go plot that. Okay, 9/8 is just slightly over 1. Bam, just like that, focus. Okay, then the directrix is just simply h minus a. Well, h is again 0 because the vertex is at the origin, so this is negative 9/8. All right, box that up. So I'm going to go behind and just a tad bit to the left of negative 1. I'm going to write directrix. And I'm going to write x equals negative 9/8. All right. What I'm missing is actually my total length of the latus rectum, okay? Total length is absolute value of 4a. And we see that a is 9 over 8. So that's going to be 4 times 9 over 8. That will give us a total distance, let's reduce, so 9/2 units. So that means it's 4.5 units, okay? That means I'm going to go up from the focus half of 9/2. So that's 9.25. Okay, so 9.25 is what I'm going to go up by. So that's going to be, so 9.25. Okay, so that's 2.25. So let's go up 2.25 from the focus and go down 2.25 from the focus and connect dots. Now, if they already gave you 1 extra point, technically, can you graph using that, reflect on the other side, using that 1 extra point that they had? Of course, but that's not the length of the latus rectum, so make sure you're super mindful, okay? They do want us to get 2 latus rectum points, so we are going to use the focus. The x will be the same as the focus x, so both of them will have 9/8. Now all we have to do is add 2.25 from the y coordinate of the focus and subtract 2.25 from the y coordinate of the vertex. Well, I'm sorry, from the focus. Okay, add and subtract 2 1/4 from the focus. So while the focus is at 0, the y coordinate, so what that's going to happen is negative 2 1/4 and a positive 2 1/4. So those are our 2 points for the lattice rectum. Okay, so make sure we have our equation box up, which we don't. Let's go and take this down here. Y squared equals 4 times A was 9/8 x, and so that's y squared equals 9/2x, and box that up just like that. Okay. For 10.2, find the vertex, the focus, the directrix of each parabola and graph it by hand. So it's going to be, I want to make sure that I am writing down all of the things they are looking for. So first, it wants us to find the vertex, find the focus, find the directrix, big D, and of each parabola, and then graph it by hand. All right, so these are all of the things that we are supposed to answer. So 2a, quantity, y plus 2 squared equals -4 times x minus 3. Because your y variable is being square, so we know that it'll either open to the right or the left. And this is negative, so we know for sure that it opens to the left. Okay. We have a few things we can find right away. First thing is we are going to find the vertex. The vertex is going to be your h comma k. So h is going to be 3 and your k is going to be -2. Next, we need to find an a value so that way we can locate the focus and the directrix. So a, it's going to be 4a, or -4a equals to -4. Or you can think of it as an absolute value of those. Since it's an absolute value, it comes out to be 4a equals to 4. A comes out to be a 1 unit. If it's 1 unit, we know that from the vertex to the focus is 1 unit, and from the vertex to the directrix is also 1 unit apart. So best thing for us to do right now is plot it out. Let me make some grids. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. Vertex is at 3, up 3, -2. So 3 down 2, label it V. We know that it opened to the left, so the focus is going to be over here. I can find that location right away. That's 2, -2. The directrix is 1 unit, aka a unit. So here's directrix. X equals to 4. X equals to 4. Okay. If we know those 3, we now need to find the total length of your lattice rectum. Length of, and it's always an absolute value for A. Absolute value for A happened to be an absolute value of 4, which is 4 units total. Okay, if I know it's 4 units total, I can go up 2 from the focus and down 2 from the focus to finish graphing by hand. And remember, I may ask you to find the location of the lattice rectum, so might as well get used to labeling these. This is 2, 0, and then this is going to be 2, 1, 2, 3, 4, -4. Okay, so those are them. We graphed it by hand, checked. We found the vertex, the focus, and the directrix of each parabola. Example 2b, very similar, except that we need to complete the square. Ready? To complete the square, we first will factor out the 2. We know the y variable is being square, so we know it either open to the left or to the right. So y squared plus something, oh, I'm sorry, not plus something yet, plus 6 y plus something blank equals negative x plus 1. We do not need to complete the square for the x because we don't need to factor that out. Half of 6 is 3, 3 squared is 9. I mean, we're going to add 9 over here, but that 9 is really being multiplied by 2, so this is really 9 times 2. This is now then factor out as a y plus 3 quantity square equals a negative x. 1 plus 18 is really now 19 plus 19. And then we're going to get rid of this 2 in the front very soon. But before I do that, I want to factor out a negative 1. So that means I have x minus 19. To get rid of this 2 in the front, I'm going to multiply that by a half. What I do to that side, I do to this side. Here is our equation. Y plus 3 quantity square equals negative 1/2 times x minus 19. This is our equation. Okay. Now I need to answer the parts that they want. Vertex, focus, and directrix. Here we go. Vertex, focus, and directrix. Vertex is always h comma k. So here's h and here's k. So that's going to be 19 comma negative 3. Ooh. Okay, well, I'm definitely not going to do 19 take marks. So for the x location, I would just do every 5 units. 5, 10, 15, extend this all the way out, 20, and 25. And the y-axis, I can stick it 1, 2, 3, 4, 5, 6, 7. Okay, so vertex is negative 19 comma 3. So it's right here. Eyeball 19. Sometimes 19 comma negative 3. So here is your v. Next, I need to find an a value for us to even find the focus and the directrix. Are you ready? A value. Well, we know that it opens to the left because it's a negative 1/2. See this right here? We are going to take negative 1/2. We're going to set it goes to negative 4a. To get rid of negative 4, we will multiply this by negative 1/4. Negative 1/4. So a will come out to be, ooh, super tiny, isn't it? A is 1/8. Oh my. So that means we are going to eyeball 1/8. So the focus, we know it opens left. So the focus is somewhere here on this left side, and it's going to be super close to the vertex. This is just 1/8. So what does that mean? I'm going to take the x-coordinate of the vertex and minus 1/8. So the x-coordinate of the vertex was 19. So 19 minus 1/8 comma negative 3 is the new order pair of the focus. Take away 1/8 is 18 and 7/8 comma negative 3. This is your focus. That gets filled in right here. 18 and 7/8 comma negative 3. And we're going to do the same thing to the directrix. The directrix is 1/8 behind the vertex. So that means it's going to be an x equals 19 plus 1/8, which is really 19 and 1/8. I'm going to try my best to graph out our directrix. I'm not going to hold you for this particular approximation. Okay, there you go. So that's going to be x equals 19 and 1/8. I need now to know find the length of the latus rectum, so I know how far up to go. Length of latus rectum, which is an absolute value of 4a, which we already know an absolute value of 1/2. Well, the total length is 1/2. That means you're going to go up 1/4 and down a 1/4. I'm going to see if I can fit 1/4 in here. 1/4 from, remember, you're going 1/4 from the focus. So here's 1/2, here's 1/4. I'm just going to eyeball this. This is going to be 1 skinny, okay, 1 skinny according to my grid. I went up a quarter, and I went down a quarter from the focus as best as I can make a quarter. Then if I ask you to find the order pairs of the lattice rectum, we can take the y value of the focus and we add a quarter, and we can also take the y value and we subtract a quarter. And remember, the reason we do a quarter is because it's half of the total length. So if I ask you to find the lattice rectum point on the top here, then we're going to take, remember, the y value of the focus. So the x value should be exactly the same. The y value is -3, and we're going to add a quarter. Of course, we simplify. So 18 and 7/8, comma, -2 and 3/4 is the top piece of that. We could also do the same thing on the bottom. I'm using different color. It's going to be x coordinate is the same, 18 and 7/8. And we're going to take the -3, which is the y coordinate of the focus, and we subtract a quarter. So this final answer for this bottom order pair for the lattice rectum is 18 and 7/8, comma, -3 and a quarter. So if I ask you for the order pairs, those are the two order pairs if it's ever asked, and that's how we find them. Example 3 of 10.2, write an equation for the parabola. First, if you look at this parabola, we know it opens up, so right away I would write the equation out, so by the time you are asked to take an exam, it's already in your memory, okay? And let's identify the vertex. Let's see, this vertex is 1, -4, so I can fill that in right away. Your h is 1, your k is -4. So x minus 1 squared equals 4 times a y minus and -4. Two negatives will make it now a positive. Well, if I can find a, then I would be good. Well, to find a, you can pick any point that's nicely, well, not all the time that I'm going to give you the dots, but if it's any point that you have not used, since I've already used the vertex, I can't use again. But my favorite point is when one of it is 0, so I would use 3, 0. So x is 3 minus 1 squared equals 4 times a. Y is going to be 0 plus 4. This is going to be 3 minus 1 is 2. 2 squared is 4 equals 4a times 4. That's 4 equals 16a. To get rid of 16, we are going to multiply by 1/16 or divide both sides by 16. This will give us a 4/16, which is a quarter. So your a is a quarter. Then all we have to do is plug it back in. Final answer is going to be x minus 1 quantity squared equals 4 times 1/4 times y plus 4. Yes, you must always simplify. So final answer is 1 minus x minus 1 squared equals 4 times a quarter is 1, which you technically don't need to write the 1 in the front. Yes, you may, but you don't have to. And this is as far as you need to go. And this example 4 of section 10.2. A searchlight is shaped like a parabolic of revolution. So a paraboloid, it's just a parabolic shape, okay? So it's a parabola shape of revolution. So just fancy for in terms of parabola. If the light source is located 2 feet, so this is what I want you guys to know right here. Light source is located 2 feet from the base along the axis of symmetry, and the opening is 5 feet across. How deep should the searchlight be? So a searchlight is in essence a flashlight. And a flashlight, I'm going to try my best to draw it for you, okay? Here's sort of and there's a light bulb somewhere in the bottom, and we have light source. So that's a light source. Now the light source is the focus from the base. So if I make the base at we're going to make the base at the origin because it's just the easiest location. So the base is at the origin, 0, 0, which is your vertex, okay, which is your h, k. So when the base or the vertex is at the origin, h and k will always be 0, 0. Now the word light source, this is where the focus is. They gave it to us. The focus is right now at 0, 2. The reason I know 0, 2 is because this is a parabola opening upward. And then they even went further and said, okay, well, the opening is 5 feet across. So this is 5 feet across. What that means is that I know this order pair. This order pair is 2.5 feet, some y value. And this order pair is negative 2.5 feet, some y value. And again, when you can, always try to put the vertex at the origin. So now what is it looking for? It says, how deep should the searchlight be? How deep means I'm looking for the height of this searchlight. I'm looking for the height means I'm looking for the y value. Since it opens up and the vertex, so let's put it back into the formula of a parabola. Opens up meaning that your formula is x minus h quantity square equals to 4a times y minus k. Well, h and k are both 0 because the vertex is at 0, so x squared equals 4a times y, since k is also 0. If I can find y, then that would be my answer. Well, I do know x. X is, according to this, x is 2.5 when y is unknown. I can definitely plug that in. So 2.5 is really 5 over 2 quantity squared equals 4. Well, I have one equation and 3 variables. I know what x is. I can plug that in. A, so let's remember, A is the distance from vertex to focus, okay, or vertex to the directrix. So remember that. Since we have the focus, A happened to be 2 feet. So plug that in and we're solving for y. So 5 over 2 squared, that's going to give me 25 over 4 equals 8y. To get rid of 8, we will multiply both sides by 1/8. 1 over 8. And y now comes out to be 25 over 32 feet. So how the deep, okay, the searchlight is is 25 over 32 feet deep. When you can, I do prefer the simplest exact answer. Start the definition for the ellipse, okay? 10.3. All right, the first definition is the ellipse. An ellipse is the collection of points in the plane whose distance from two fixed points these two fixed points are also known as the foci, add up to a constant number. Okay, now the foci are two fixed points on the interior of the ellipse. Okay, so you guys remember the parabola had one focus. Okay, now the ellipse has two foci. which is two of them. So what does that mean by these two definitions? Let me just give you a little picture in which we will probably draw a lot more pictures in a little bit. So let's call this foci 1 and foci 2, okay? And it's made up of, and it says here, collection of points. I mean, every single exterior here, these are all points that's made up to, that's collected to make an ellipse, okay? Then it says, collection of points in the plane whose distance from two fixed points. So let's say I'm going to pick that point, this distance, and that distance, okay? If I add those two, let's call that should be the same as if I were to pick this point and add that with that, okay? So the distances in red, if you add those two distances, should be exactly the same as the two green distances. And let's say I want to pick this point. From here to there should be the same as if we would from here to here. Let's just, they should be on the same exact line because the two foci should be on the same exact horizontal line. But because I don't want to draw it on the same one because you can't see, but this distance here from foci 1 to this dot here on the right side, add that to focus number 2 to the same dot. That should be the same exact distance as the red and as the green. And if I want to go further, we can even make, okay, well, what if we want to make this dot? Well, that distance plus that distance, all of those distances, when I add them up, the blue should equal the red should equal the green should equal the black. So that's what it means to be an ellipse. Okay, so that's the definition of the ellipse. With the two fixed points, which are called foci. Okay, if you take the distance from the two foci to any point on the ellipse and you add them up, they should give you the same constant. All right. Major axis. Let's move on to that. Is the line containing the foci. So that's why earlier I said the focus 1 and focus 2, the two foci, should be on the same line. So this is now called the major axis, okay? All of that right there. Focus 1, focus 2, so two foci, same major axis, all right? Minor axis is the line through the center and it's perpendicular to the major axis. The center is the midpoint of the major axis. Major axis or minor axis. Okay, so the minor axis, if we use the same picture, is going to be goes through the center and is perpendicular to the major axis. So here's the center right there, okay? Vertices are 2 points of intersection of the ellipse and major axis. Okay, so what do I mean by that? So the vertex are the 2 points of the ellipse, which is the outer, and where the major axis is. So those are vertex 1, vertex 2, together they're called vertices. The length of the major axis is the distance from one vertex to the other vertex. Now, normally, I would ask you to use your electronic device to define the whispering galleries, but I'm just going to give it to you in this set of notes, okay? Whispering galleries are domes that are constructed in a way so sounds produce at any certain point are clearly audibles at another location. And we need to know this fact because this will be used in our application later, okay?